Okay. So this is a linear system. We'll call it linear systems. And there's lots of different ways to go about solving linear systems. Technically, we can use graphing as a method. We can use algebra. I never spelled this one. Algebra. And then from within algebra, we have substitution as a method and elimination. Okay? We're going to focus on substitution here. So I have two questions, or I should say two equations, just one question. And these both represent some line on a graph. Oh, there's my dog. We don't quite know, so I'm just going to give us a rough estimate or a guess. It's not even an estimate because I don't really know any of the values. But essentially what happens is they're going to intersect at some point, and that's what we're looking at trying to solve. What are the x and y coordinates of the point where they intersect? So for substitution, what we want to do is essentially, just like the word says, we want to substitute one equation in for the other. So we have equations 1 and 2 here. What will work best is if we actually set one of the equations equal to a variable. So in each of the questions, we have the variable x and we have the variable y. So we have our choice. Which equation do we want to set it equal to? Really, it doesn't matter. You could change. You could set it equal to x in equation 1, y in equation 1, x in equation 2, y in equation 2. It makes no difference. But from some experience with working with this, I'll tell you that the fastest method right now will probably be to set it equal to the y in equation 2, just because it doesn't have any coefficient in front of it. So it's going to be the simplest. Doesn't matter. I'm just giving you a little tip there. If you ever see one with a coefficient of 1, it'll be easiest that way. So I'm going to take equation 2 down here, and I'm going to rewrite it. And my very first step here is to set it equal to y. So that's going to be our goal. I'm going to highlight it so we kind of remember this the whole time. We got to set this equal to y, which means I got to move 6x to the other side. Now, as long as you're familiar with moving things to the other side, it really just means you're using the opposite operation of the absolute value on both sides of the equation. What does that look like? That's just saying we're going to take negative 6x on both sides of the equation. On the right side of the equation, it creates a 0, so we don't write anything else. And on the left side. And then on the right side, we have a constant 2 and another variable here. So once we've done that, we've actually accomplished step 1. We have set something equal to y. In fact, this is exactly what is equal to y here. We'll put it in brackets. The reason this is important is because now what we can do, because we have a value from equation 2, we can go back to equation 1 and replace the y with the right-hand side of what y is equal to, okay, in equation 1. So let's write that back down here, and hopefully it makes a little sense to you. So I'm going to retake equation 1. We have 2x minus 3y equals 4. Okay. It turns out, and I can rewrite this as equation 2 if I want, y is equal to 2 minus 6x. It's the exact same as before. I've just rearranged it. But why it's helpful, no pun intended with the word y there, why it's helpful is because this y can now replace that y. In other words, this whole part of the equation can be plugged into there. So now we're going to focus on equation 1. We have 2x minus 3, and instead of just writing the letter y, we're going to write everything that y is equal to, which is 2 minus 6x. The reason we do this, when we go ahead and look at this, we're going to focus on it now. The reason we do this is because now in equation 1, I only have the variable x. So I only have one variable, which means I can solve for this. In math, if you have one variable, you just need one equation to solve for it. I'll have to do some algebra. I'll have to use distributive property here and then collect like terms. But in the end, I know that technically I can solve this. So I go 2x. When I distribute that negative 3, that's going to become negative 6. And negative 3 times negative 6x will become positive 18x. Just put them in yellow to show that things have changed. Okay. From there, we want to collect our like terms. So these x's are like terms, and these constants are like terms. So I'm actually going to move the negative 6 over. So we're left with 2x on the left-hand side plus 18x. Those things didn't change. And then when we bring 6 over, it will become plus 6. So we'll do both sides at the same time now. 2x plus 18x gives us 20x. We just add the coefficients. 4 plus 6 is 10. And again, our goal is to find the x and y value. Well, I can just isolate for this x here. I'll divide both sides by 20. And it turns out x is equal to 1/2 or 0.5. Okay? That's great. If we go back up and take a look at what our ultimate goal was, well, our ultimate goal was find x and y value. We have an x value. It's 1/2. We don't have the y value, though. So what can we do? We can go back to both the original equations, and I can plug in my new value of x for either of these equations, and we'll still get the same y value. So to prove that, I'm going to see if I can take a quick copy of this. I'm going to copy both of them. Oh, that's the opposite of what I want to do. Oh my gosh, did I just lose it? No, I didn't. I just moved over. Good. Sorry. I thought I was going to be faster doing this, and I'm not. Scroll down. Can I paste? I can't. Okay. I thought I could do something that I can't. I'm just going to rewrite it here. Equation 1 was 2x minus 3y. So I'll go to the bottom here. Equation 1 is 2x minus 3y was equal to, and I'll go back up and check it out. 2x equals 4. Okay. And technically in my equation 2, I can do that one also. 6x plus y equals 2. We'll zoom back in. So from what we had just found, x is equal to 1/2. That means I can replace this x or this x. So just to show, and this again is still substitution, we're going to substitute that value in and see what we get as a y value. So here we'll have 2 times 1/2 minus 3y equals 4. Okay, and I'll do the whole equation 1 first, and then we'll go to equation 2. 2 times 1/2 really nicely becomes 1 minus 3y equals 4. When I move that 1 to the other side, I'm going to get negative 3y is equal to 4. Okay, go talk with mommy. 4 minus 1. That will become 3. So we have negative 3y equals 3. We're going to isolate for y. So we divide by negative 3 on both sides. And lo and behold, we get y is equal to negative 1. Okay? And to confirm this, we're going to do the exact same thing in equation 2, just to show you that it doesn't matter which one we use. 6 times 1/2. Remember, x was equal to 1/2 plus y equals 2. 6 times 1/2 happens to be 3 plus y equals 2. When I move that 3 to the other side, it becomes 2 minus 3y is equal to negative 1. I got the same answer. So in the end, our point of intersection was 1/2 and negative 1. Let me erase that, please. Okay, so we zoom out a little. Oops, that is the opposite of out. There we go. So this was kind of our whole, we'll go one more time. This was everything we did there to solve that question.